Today's video will be about a new model used to predict cognitive decline in Alzheimer's patients. This model was developed at the Massachusetts Institute of Technology. In the MIT Media Lab, researchers say that a new model developed at MIT can help predict if patients at risk for Alzheimer's disease will experience clinically significant cognitive decline due to the disease by predicting their cognition test scores up to 2 years in the future. Before we dive into this, let's briefly review Alzheimer's disease. Alzheimer's disease is a neurodegenerative disease that slowly worsens over time. Being the most common form of dementia, it causes 60 to 70% of dementia cases. The first part of the brain that is typically affected is the hippocampus. This is where we see decline in memory and navigation for some patients. Some pathophysiological changes involve amyloid plaques and neurofibrillary tangles that promote neuronal loss. According to the Alzheimer's Association, nearly 5.8 million Americans are living with Alzheimer's disease. 1/3 of seniors typically die with Alzheimer's disease or some form of dementia, and it's the sixth leading cause of death in the United States. A lot of grief comes with coping for Alzheimer's disease, and the researchers in the study hope to improve clinical trials in the sense of candidate drugs and participant cohorts. This type of research has been very unsuccessful. Based on the looked at data, since 1998, we've seen 146 unsuccessful attempts to develop a drug that is meant to treat or prevent Alzheimer's disease. They hope that their newly developed model can help prepare patients and loved ones for the expected cognitive decline. Through knowing in advance, the number of patient visits in regards to the disease can reduce and save individuals a lot of money. So how does it work? They refer to the largest Alzheimer's disease clinical data set that has details on memory, language, orientation, MRI scans, demographic, genetic info, and cerebrospinal fluid measurements. For their dataset, they used a subcohort of 100 participants that made at least 10 or more visits to the doctors. Out of this, 48 of them were diagnosed with Alzheimer's disease. Because some of their data for each individual patient was sparse and not everyone had every detail filled out, they used a different type of process used to fill in those gaps. I might be pronouncing it wrong, but it's referred to as the Gaussian process, but I'll just refer to it as GP. So through this, after every doctor visit, the GP process fills in those gaps, like I said, and after 4 visits, they saw an error rate reduce significantly, up to nearly 50%. The meta learning scheme was developed to improve results to choose which type of model should be used for an individual. So they had two types of models, personal and population. The personal model would be used when a patient starts with more data through subsequent visits, and then the population model would be used when the patient has noisy, sparse data. In the paper, I have it in the details at the bottom of the video, but if you want to look at the mathematical requirements in regards to each model, they have it in better detail in the primary article. So from this data, they hope that one day that they can partner with other pharmaceutical firms to implement this model into real-world Alzheimer clinical trials. Thanks for watching.